Welcome to part 3 of this video, limit continuity. Today I'll be taking you through this question on how to evaluate the limit of this function. The question is here before us. They say that let g of x be equals to x plus 3 such that g of x is continuous at 3. So you are to let g of x to be this function we are given. The function g of x is x plus 3 such that the function is continuous at 3. I will take you through that shortly, but let me say something briefly. If you are given a question and you are asked to show that the limit continues at some certain variable or certain number 3, 2, 1 or whatever, and you solve the math and you found out that the limit does not continuous, don't force it. Students make this mistake. You are asked to find the limit and its continuity at a certain number or a certain variable, and you did the question and you find out that the limit does not continue, but because the question says the limit continues at that number, you want to force it. In mathematics, we don't force answers. It has to be systematically, it has to be proven. You don't get answer, you don't assume it, you just get it from your calculation. So if you find out that the limit does not exist, kindly don't force it. Make your statement that the limit does not exist. But if the limit exists, why not? So let us see if this limit continues at x equals to 3. So now, let's see. We are going to solve this limit from the left-hand side and from the right-hand side. And the question was to show that that limit continues at x equals to 3. So we are going to assume that the limit as x turned to 3 from the negative of the function g of x. The function g of x will be given by x plus 3, which we were given. So we just do our direct substitution. But since this is negative, it approaches negative. It approaches 3 from the negative side. It means that negative 3 plus 3. So you have to put this negative side to show that it is from the negative. And if you solve this, you get 0 because negative 3 plus 3 is 0. Now, from the positive, x approaches 3 from the positive. It means that 3 is positive. So it is 3 plus 3, which is 6. Now you can see that the limit from the right hand side is not equal to the limit from the left hand side, because the left hand side gave us 0 and the right hand side was 6. So therefore, limit of this function g of x from the left is not equals to the limit as x turned to 3 from the right. So we can say that the limit does not exist. But now you have concluded it does not exist, but the limit tends to 3. So you have proven that the limit as x turned to 3 from the negative is 0, and the limit as x turned to 3 from the positive is 6. Even though the limit does not exist, but the limit will be continuous at 3. For more clarification about this video, refer to part 2 of this record. Otherwise, all the best. I remain your humble friend, Galagash. Don't forget, subscribe.